Hello there. I hope you're doing well wherever you're watching me from. So there's this kind of debate for students who are taking physics igcse, that is 0625. The debate is all about whether they sit for physics paper 5, which is doing the practical, or physics paper 6, which is the alternative to practical. Now, let me just tell you that in your certificate, there will be nowhere indicated whether you did alternative or uh, alternative practical or the physics practical. There is nowhere that will be indicated. But there are some few differences that you need to know. I will highly recommend, where possible, if you're a student who wants to continue with sciences, maybe in A level, please, I will ask you to consider sitting for physics paper 5. But if let's say that you're just doing sciences for fun, and probably maybe your career is not in line with with sciences, then there is no need. Of course, there are also other factors. For instance, if you're doing homeschooling or you're a private learner, access to laboratory may be a challenge. And that is why we have Masit Lab Academy. We are located here in Kilimani, where we support students to do practical. If you're somehow far from Kilimani, let us know. We will do mobile. But if you're watching me from a country outside Kenya, no problem. We will also be coming for you. But anyway, whatever reason that you have to do any particular paper that is known to you, but I just wanted to let you know that it is okay to do either of the paper. If we look at the content of these papers, you will realize that they all have the same content. It's only that now one you are doing practical and the other one you are not doing the practical, and probably also the code. So if you look at, so this is physics paper 6, alternative to practical. That means it's just theoretical questions testing the practical skills or the experimental skills. The code there is 062561. I have picked May, June, and you can able to see this is 1 hour. I want to compare it with this paper that is done almost the same time. That is paper 5. So paper 5, which is the practical test, 0625 variant 51, May, June 2016. There's an additional of 15 minutes. So that is number one difference that you can able to see. Of course, there are two differences there. So this is practical test. The other one is alternative practical. So let's look at the content here. Now, if you can able to see here, paper 5, there are how many questions? There are 4 questions. And all of them, they add up to 40 marks. So this also have, they don't write, but this also have 40 marks. So it is also out of 40, 40 marks. Though it's not indicated, but don't worry. Let's look at the content. So this is the practical. So practical, you are given a diagram and you're given some kind of instructions to follow. Once that is done, so as you're able to follow the instruction, you are given data where you're supposed to record. So you're given table where you're supposed to be recording your data. For paper 6, let's see, the same diagram, but now what you're given here, you are given actually the data that you need. And you will realize that for A and B, you will need to use a formula, which you can able to see it is actually given here. So you're given a formula to be able to use to fill the values for A and the values for B. So, and then now, of course, you'll be expected to fill the headings there. So paper 6, you are given data, but the calculation parts you have. And you can able to see how many marks is that? That is about 2 marks. 1 mark for completion, and then another 1 mark for the headings. But if you look at this for practical, that is 3 marks. So then we have part B, where you're supposed to draw the diagram, the graph, and I think that should be the same for even this. And let's see if the questions are the same. The questions are all the same. Now look at part F. Use the balance provided to measure the mass of the material. So I think this one here, suggest one practical reason why it is difficult to obtain. So a few questions may vary, but the content is more or less the same. If you look at, you see now here, the weight has been provided, but the other side you are being asked to measure. For question number 2, this is alternative to practical. You can able to see clearly the voltmeter reading, the scale is given there for voltmeter and ammeter. Now, what you need to do is just to pick in, understand the scale that has been used, and then use that to record your values of what of V and I, highlighting the, of course, indicating the unit. Let's look at this number 2. Number 2, you are given the diagram. The setup will be done by the technician in the lab or whoever is involved for preparation. And then now you need to fill in the data, and that is 4 marks. But you see, for this one here, the questions are somehow slightly different. Oh, sorry. Okay, question number 2. How is it mixed with the water? Anyway, I haven't read the question directly, but there's number 3. So question number 3 is comparing with this question number 2. Just some small variation, and you'll be able to look at it. If you look at the other question, this is about light. Let's see if there's also something to do with light. No, so that is where there's a difference. So there's some kind of small differences in the question, but believe me, the content are more or less the same. They're testing more or less the same scales. Though for paper 5, you are doing it by yourself. Your values are what you have. So you have to know how to do the practical. For paper 6, you just need to understand how to record data. Calculate, all that is done. Let's look at question number 4. A student is investigating the effect of insulation on the rate of cooling of hot water. Look at that. And even that is question number 4, the planning one. And look at the one for paper 6. Paper 6, you can able to see clearly they are all the same. So today, I want us to take some time to understand how we can able to answer a question like number 4. How do we answer planning questions? Sometimes it can be tricky. What do you need to consider so that we can able to answer the questions effectively? I will, wonderful. There was still part 5 here. I didn't scroll down. Wonderful. So the content is the same. Wonderful. Great. So I want to use this space here so that we highlight a few things about question number 4. So the moment you are reading a question, the moment you're reading the question, please, you need to be able to understand a few things. You need to understand that every time you are doing a practical, so whether you are doing any practical that you're planning for, you must be able to understand the variables which are involved. And which variable is this? We are talking about independent variable. Independent variable. Forgive my handwriting. Independent variable. We are talking about dependent variable. Dependent variable. Then the next one, we are talking about control variables. And I want to use big English or whatever big language here to explain what they mean. Independent variable, it just means the variable that you can able to change. The variable that you can able to change. And we're going to look at the example step by step. We'll actually start with the question that is here so that we look at how to understand. So what about control variable? Control variable is a variable that we need to keep the same throughout. We need to keep it constant. Actually, the best word is constant. We need to keep these variables constant. Their value should remain constant. If you're investigating how PD and current relates across a constant conductor, then the length of the conductor, the cross-sectional area of the conductor must remain the same so that you can able to have a fair test. So control variables are those variables that must be kept constant so that you can able to have a fair test. For instance, let me give you a funny example. Like for example, a fish. So you have a fish here and you have a rabbit. So if let's say you want to investigate how a fish how a fish and a rabbit they can able to run, then you must keep some kind of some kind of variables constant. For instance, a fish cannot able to move on the land. A rabbit cannot able to move on in water. So if both of them are placed in water and then you want to know which one is moving faster than the other, then I think your experiment will not achieve its goal since the ground is not fair. That is just an example of a fish and a rabbit that you can able to think about. But of course, you're not going to have fish and rabbit in the physics. Let's have an example. So before we look into another point that you're supposed to be considering for paper 6, let us look at this question that is here. Actually, I can just use this directly. So a student is investigating the effect of insulation on the rate of cooling of hot water. So the first statement here, there is something about the effect of insulation. And then the other thing here is about the rate of cooling of hot water. So one of these must be dependent variable. One of these must be the independent variable. There are some questions whereby the variables are very clear. You can able to see them. Actually, the first statement, we'll able to do another example whereby the variable is not clear in the first statement. So here it is very clear. We want to see the effect of insulation, meaning we will have the power to change the insulation, and then we look at the effect it has on the rate of cooling. So that makes the effect of insulation to be independent variable. So let me just call it IV, independent variable. Then the rate of cooling, because this rate of cooling depends on the insulation, so this become now the dependent variable, dependent variable. Now we think, we haven't even gone through the question yet. We haven't even gone through the instruction. We're just trying to think. For me to investigate the effect of insulation on the rate of cooling, probably you will have something like maybe a beaker somewhere. You need to have some hot water somewhere that you want to cool. Then that means that a few things must be kept constant. For instance, something like the volume of water. The volume of hot water that you're going to use, it must be the same for us to have a fair test. If you look at the environment where you're going to do experiment, let's say the first experiment, you do it in a room, the other experiment, you do it outside the room, that will affect your results because maybe there may be a change of temperature in either way, depending on the environment where you are. So the room temperature should also remain constant throughout this kind of experiment. So we talked about the volume, the room temperature, the initial temperature of hot water. We're just thinking about points. The initial temperature of the hot water. Initial temperature of the hot water. So what does it mean? Remember, if let's say the room temperature is, let's say, 16 degrees Celsius, and the hot water is about 80 degrees Celsius. This is, let's say, for condition number 1. Condition number 2, the initial hot water is, let's say, 60 degrees Celsius. When the temperature difference is low, then it is very obvious that the rate of cooling is also going to be low. That's why we are saying that if you want to have a fair test on the same plate, then the initial temperature of the hot water for this particular experiment here must be the same. We've talked about insulation. Probably, let's say, insulation means different things. Maybe we're going to have different cans made of different materials. So we're going to look into them. Or probably we're just going to use one can, and then with one can, then we have maybe some kind of thickness of insulators we're going to use. Meaning, if let's say we're using thickness of the containers, thickness of the insulators, what does it mean? It means that the thickness must be the same. the thickness of the insulators must be same. So that maybe you have thickness number 1. So maybe you have 3 or 4, 5, 6 thickness. I will be able to draw. So you have something like this. This is a beaker, and then you are putting some, maybe whether it is cotton or just a material that is made. So you'll be adding thickness around it, something like that. So anyway, that is just thinking weirdly as we are starting, but just to get to understand what we mean by these different types of variables. So we have independent variable, dependent variable, but please, there'll be no mark for mentioning, I don't know, independent variable. There'll be no mark for mentioning dependent variable, but most of the time they always ask for control variables. But then just in case, if they ask you what is independent variable, which value there is a dependent variable, wonderful. Now you know how to identify. That's okay. Let's dive into it. So the student can choose from the following apparatus. There's a thermometer, there's a 250 cubic centimeter of glass beaker, there's a plastic beaker, copper can, a measuring cylinder. Then we have 3 different insulating materials. Wonderful. We have a clamp, a boss, and a stand. That means a complete stand. Wonderful. And then we have something, a stopwatch, because we're dealing with the rate of cooling. Sometimes they can even ask you, is there any extra apparatus that they need? Now, plan an experiment to investigate the effectiveness of 3 insulating materials. You are not, very, very important, you are not required to carry out the experiment. It is always in bold. The word not is always in bold. This is a planning experiment. A planning experiment is that, like, you assume that you're giving instruction to someone else, such that should they follow that instruction that you're going to outline here, then they should be able to carry out that experiment. All right. So we are being asked. So remember, the question is very, very specific. We are investigating the effectiveness of the 3 insulating materials. Meaning, if this question was just open, then we could have even tested like a glass beaker, plastic beaker, or copper can. But because the insulating material we're investigating, we have been given these 3 ones, those are the ones that we're going to use. So it therefore means that also for a fair test, we must use 1 beaker for the entire experiment. So you cannot use 1 insulator on 1 beaker, another insulator on another beaker. Please just always ensure or know that every time you are given all these apparatus, you don't need to use all of them. That is why they have told you, you can choose, a student can able to choose from this. Let's just go to the instructions here. So briefly explain how you will carry out the investigation. And then you have been asked here, you may draw your diagram if it helps to explain. I can take a few seconds to draw that. So all right, so here is it. I have a sketch of what I want to do. So I've already labeled. It's a well-labeled diagram. This can give me even a mark. If the method is explanation is about 2 marks, this can give me at least a mark, as long as my diagram is well labeled. So now I need to explain. So because I've done my diagram, so I can able to say that set up the experiment as shown above, because I have drawn. So please, if your diagram is below, please just say that it is below. And because mine is above, that is it. So set up the experiment as shown above. Then what are we going to do? We're going to so we're going to pour hot water. Hot water. I want us to be specific so that because now the volume of hot water is supposed to be the same. So I want to capture that point actually within this here. So I want to say that using a measuring cylinder, you remember there is a point using a measuring cylinder. Measure volume of hot water. I can even put these remain constant throughout the experiment. These remain constant throughout the experiment. Throughout the experiment. So, and pour it in the beaker. Now from here, there are options. You are the one to decide. Either you want to make the temperature to be fixed, meaning that maybe probably you decide to measure how long it takes for maybe the temperature to decrease at a given fixed interval, or you want to measure the temperature at an interval of time, or you want to measure the temperature from at the start and after a fixed amount of time. So it is your decision which one works for you. So for this, I will choose one. Of course, you only have to choose one. So measure the temperature of the water at fixed interval of time. Remember, we are not doing experiments, so I'm not going to say here measure maybe after every 5 seconds, after every 5 minutes. No, it is upon the person who will be doing the experiment. Mine is just to guide. So measure the temperature of water at fixed interval of time. Then now, after doing that, remember we had already put the insulator here. So this is just for one insulator. So what I want to tell this person is to repeat what we have just described here for the next remaining insulators. So repeat for the remaining insulators. As you record temperature, time, and the number of insulators. All right, so that is description. So we have just explained that. Now state the key variables that you'll control. So if you're very keen, there's already a mark here that I will be able to get, because I had already mentioned here, keep the volume in a silent way. This amount of volume will remain constant. But anyway, the volume of water, I don't want to repeat that. because I already have the points here. There's some point that we've already put here. The room temperature, or the initial temperature of water, the thickness of the insulators, the room temperature, should remain constant throughout the experiment. Should remain constant throughout the experiment. So I have already highlighted the key variables that should be kept constant. Then the next part that we need to understand is that you need to draw a table or tables with column headings to show. The table is always 1 mark, but if it doesn't have the column headings and the unit, you will lose that 1 mark. So the method that we chose will require like a large table where we have, because we have insulator 3 of them, so we can have here insulator. So when there's only one insulator, when the insulators are 2 and when the insulators are 3, that means here there will be temperature in degrees Celsius, and there will be time in seconds. So now you can able to see clearly for insulator 1, once you do for the first insulator, once you do the experiment, you'll be able to collect data here, temperature and time. For insulator 2, you will plot, you will have those temperature, time. Insulator 3, the same. But then it depends on the method that you're using. For example, if let's say someone choose a fixed starting time and end time, they just want to see the temperature change, then that can also be, that would be a different case for the entirely. So now the table that you choose depends on what you've described there. So for my case now, what is remaining? Explain how you will use your readings to reach a conclusion. So to reach a conclusion, if the kind of method you've chosen encourages large data, then we'll be able to say here, plot a graph of temperature against time on the same axis for each insulator. You see, that means we're able to have like 3 data on the same. So from there, once you just say plot a data, then that will enable you to reach a conclusion. So that is how we respond. This is just a sample. I want us to do another example so that we be confident in this kind of question. So another example, I want to use a concept about electricity. So I got this question. This is 5/1 October, November 2018. Once again, I am taking you through how to respond to question number 4 of either paper 5 or paper 6 of physics 0625. Now, a student is investigating the relationship between power produced by an electrical heater and the time taken to heat a beaker of water. The power of the heater is given by the equation P is equal to VI, where V is the potential difference across the heater and I is the current in the heater. Plan an experiment to investigate the relationship between power produced by an electrical heater and the time taken to heat a beaker of water. You are not required to carry out this investigation. Okay, before I proceed there, do you have any idea of maybe the dependent variable and the independent variable from here? You're trying to imagine what is being done here. So the power of the heater, of course, will be able to affect how long a given amount of water is going to be heated, or the temperature, the final temperature of the water. So, no, sorry. So the power will actually affect the time taken. That means if other factors are kept constant, and those factors to be kept constant are so assuming that we have a given amount of water that is here, and we are changing the heater. So this is, let's say, the heater that we're using. So we're changing the power. So it's, let's say, the power, initially the power is, let's say, 40 watts. We increase this to maybe 200 watts. We increase this to maybe 1,000 watts. Of course, how long that amount of water will be heated will change. But then that can only happen, I mean, in this experiment, it can only happen if, let's say, the amount of water that is being heated here is the same throughout. This can only happen if we are using the same beaker, the material, copper, a material, a beaker made of copper or a beaker made of glass. That would be a different thing. This can be different if the change in temperature is the same for all. You see that? So if we want to change the temperature from, let's say, we don't want to care the initial or the starting, but now we want to think of the change in temperature. So let's say the temperature is changing for, let's say, 20 degrees Celsius. That should be the same throughout for all of this experiment. So if we look at, oh, okay, before that, I just thought of another point here. The room temperature. The room temperature should remain the same. Why? Because if, let's say, you do one experiment in a room where it is hot, what does it mean? It means the temperature of the liquid you're investigating will rise more than if you do an experiment where the room temperature is very low, like the way it's called right now. I'm here in Nairobi. So things like that can change. Anyway, that is just thinking from using the first statement of this question. We don't know whether what is needed, but now let's go to the question. So always, juggle something, write something there to make you understand, to help you take control of this kind of question. So plan an experiment to investigate the relationship between the power produced by an electrical heater and the time taken to heat a beaker of water. You are not, and is in bold, you are not required to carry out this investigation. The following apparatus are available. We have an ammeter, voltmeter. When you look at an ammeter, we are talking about current. When you look at a voltmeter, you're talking about a potential difference V. The power supply is there. The 250 cubic centimeter beaker is there. I think we're going to use this to be heating. The heater, whose power will be varying, and then the thermometer, and then a stopwatch. So in a normal laboratory, or in most of the laboratory, we don't have a device that measures the power directly. And that is why we are actually being given that formula there, that power is given by I and V, meaning we'll be measuring current and voltage or potential difference across that heater. As we do that, that will be able to give us the power. I think you have an idea now. And then a stopwatch. A stopwatch, not watch, okay. A stopwatch to measure the time taken. So the heater is here. Okay. This is the heater. All right. All right. So complete the diagram in figure 4.1. So this is the figure 4.1 to show the circuit that you will use. So in this circuit, I need to measure, these are the variables. So P is given by IV. So I need to put current there. So the power source, I will just have that as the power source. We'll have an ammeter, We may want to vary. We may want to vary the current so that we get different set of current. So probably a variable resistor here, and then one side is connected to that, and then this side we connect to this. Now the voltmeter should be across. The voltmeter should be across the heater. So the voltmeter should be across the heater. So that voltmeter will be connected here. Of course, you don't want to connect the voltmeter in water. It doesn't make sense at all. So here we go. So what are we supposed to do? So this we are supposed to have. So once we have that, that is correct. And then now, what are we going to do? The method is just to measure, the potential difference across the heater and the current using the ammeter, though this is a repetition, using the ammeter and voltmeter respectively. So what next should we do? So using a stopwatch, measure the time taken, measure the time taken for a given change of temperature. You want to know how long, that is what we're measuring. That means, were we given a thermometer here? Oh, we were given a thermometer. So the diagram, we could have introduced a thermometer somewhere here. We label this thermometer, yeah, for given change of temperature. So we can repeat this, setting up different values of I and V using the variable resistor. So every time we change the set of variable resistor, we get different values of I and V, and then we repeat that experiment. So let's find out. We are also asked to set the key variables that you will control, and I think the amount of water to be used should remain the same. The temperature change should remain the same. The room temperature should remain the same throughout. Draw a suitable table. So remember, you're not doing the experiment. So the table that we want, we will have current measured in amps. We will have potential difference measured in volts. And then with I and V, we will have power, which is in watts, because you can able to calculate power using IV. And then from there, we need to have to record time taken for each. So this is the kind of table that we need, that is having units. And please, we are not doing experiment, so therefore you cannot record anything in that table, any value in that table. And then explain how you will use your results to reach a conclusion. What I will do, I will plot a graph. So I'll just say here, plot a graph of power against time. That is it. Remember, I didn't do experiment. So even if I know theoretically, I didn't do experiment. So therefore, I cannot state what you're going to expect, whether it's a straight line passing through the origin. I don't know. And if I just want to make my, if I have some time, I can actually sketch a graph like this, that plot a graph such that we have power here, power in watts, and then time here. So remember, anytime you're doing experiment whereby time is a variable, time is always in the x-axis regardless. So that is it. So that is briefly. So with question number 4, testing about electricity is always very direct, just the way you've seen. And I hope that was helpful as you prepare for your exam, or just maybe trying to understand how to do the planning questions.